All right, number 14, it says the factorial function is defined for positive integers as in factorial. So if you've not seen this, this is explaining how to do factorials. You just multiply the number that you're starting with and you subtract 1 and you keep multiplying all those until you get down to 1. So for example, if I start out with 4 factorial, looks like an exclamation point, but in math we call that a factorial. How you solve that, you would do 4 times 3 times 2 times 1. And if you multiply that, 4 times 3 is 12, times 2 is 24, times 1 will still get you 24. This is also in the calculator, so if you have a scientific or graphing, I'm going to go to the home screen, type in 4. If you go to math, and you're going to go over to probability, so I'm going to arrow back and just get there faster. Option number 4 has that factorial, so if you do that, it'll do it for you as well. So what we want to do is we're going to make a table of factorials 1, 2, 3, 4, 5. We're going to graph these points and connect them, and then we're going to find the least value for which n factorial is greater than 10 to the 6. So we can punch these in one at a time. It won't be a problem. We did 1 factorial, 2 factorial, 3 factorial, and so on. That'll just give you 1. 2 times 1 will just give you 2. 3, you would do 3 times 2 times 1, and that'll give you 6. We just did 4. That gives you 24. If you do 5 factorial, you do 5 times 4 times 3 times 2 times 1. However, what I'm going to do is I'm going to use the calculator to kind of speed this up, and we're going to just clear out what we had. And here you use x as your variable, they're using n, we're going to use x, that's what the calculator's input is. And I'm going to say just do x factorial. And the calculator is going to understand that I want it to plug in the whole numbers 1, 2, 3, 4, 5. And if I do second graph to see the table, I can see those values. Whenever I plug in a 1, I get a 1. That's what I wrote here. Whenever I plug in a 2, we get a 2. When I plug in a 3, we get a 6, 4, 24, 5, 120, and so on. So I'm going to just input those here. 1, 2, 6, 24, and 120. Then we want to see what that would look like graphically. So it looks like it's going to be a curved line. Again, whenever you do graphics, you want to try to see what each line is counting by. So the horizontal axis on all of them look like it's counting by ones. 1, 2, 3, 4, 5, 6. The vertical axis, however, is counting by a different value. Looks like maybe 20, 40, 60, 80, 100. 120, 140. So yeah, each ticket mark is 20. So when you do your first order pair, 1, 1, we're going to be, that means we will have moved over 1, but since that's 20, it won't be halfway. It's going to be really close to that bottom line. So this one looks good, maybe this one. So we're looking at C or D as potential answer choices. All right, so when we go to 2, we still be pretty close to that line. That one looks like it's quite a bit of a jump. Since this is a gap of 20, going up a very small amount would represent that. So C, based on trying to plot the first 2, looks like the best match. Now the calculator won't graph factorials because that function only counts whole numbers. So even if you were to go to graph, you wouldn't see anything. I think my best estimate was, I don't know, I tried zoom decimal to see what that would show you, and for some reason it kind of shows a couple little points, but it's going to be a curved line. But you can kind of plot that on your own to get an image. Now the next thing we want to know is if I keep going, if I do 6 factorial, if I do 7 factorial, what is the smallest number that's going to get me greater than 10 to the 6th power? So if we go back to the table, we can just kind of arrow down and we can see. So normally you would just kind of guess and check and plug them in. And it's not until it looks like we get to the 10th number that we have this e to the 6th. That's what we mean scientific notation, e to the 6th. When it says e, that's the calculator's way of saying exponential or exponent. That's the same thing as saying 10 to the 6th power. So at 9, we're not quite there yet. Okay, we got to get into the billions, because this is no millions range. 6 zeros be millions. And we're not there yet. We're still in the 100,000s, but when we get to 10, that's when we cross over into the millions. So when n is equal to 10, that is the first factorial that gets us over a million, which is 10 to the 6th.